How does climate change affect atmospheric conditions in the Arctic and Antarctica? If you're curious about how climate change is impacting the atmospheric conditions in the Arctic and Antarctica, you're about to uncover some fascinating and critical information. Let's start with the Arctic. This region is often called the Earth's canary in the coal mine for climate change because it's warming at a rate that's up to 4 times faster than the global average. This rapid warming is driven by several key factors. One of the most significant is the albedo effect. Essentially, snow and ice in the Arctic have a high reflectivity, bouncing a lot of sunlight back into space. However, as temperatures rise and ice melts, darker surfaces like open ocean and exposed land are revealed, absorbing more solar energy and leading to further warming. This self-reinforcing cycle is known as Arctic amplification. The loss of sea ice, especially during summer months, is a major contributor to this enhanced warming. As the Arctic Ocean absorbs more heat, it not only melts more ice, but also accelerates the melting of permafrost and glaciers. Permafrost, the frozen soil that underpins much of the Arctic, is thawing rapidly, releasing methane and carbon dioxide into the atmosphere, which in turn amplifies global warming. In addition to these changes, the Arctic is experiencing more frequent and intense wildfires, particularly in areas like Alaska and Siberia. These wildfires release more greenhouse gases, exacerbating climate change and threatening habitats for species like caribou and salmon. This has severe implications for the food security, infrastructure, health, and cultural identities of people living in the Arctic. Now let's shift our focus to Antarctica. Here, the story is a bit different but equally compelling. The Antarctic ozone hole has had a significant impact on the climate. As stratospheric ozone concentrations have fallen, temperatures above the continent have dropped, creating a larger temperature difference between the tropics and Antarctica. This affects southern hemisphere weather patterns, including an increase in wind strength over the Southern Ocean by about 15% since 1980. Tropical storms and monsoons also play a role in Antarctic climate change. These storms create waves high up in the atmosphere that travel to higher latitudes and disturb polar weather patterns. This has contributed to the warming of West Antarctica in the late 20th century. Moreover, the Southern Ocean has warmed and freshened due to both the ozone hole and increases in greenhouse gas concentrations. Another critical aspect is the impact of greenhouse gases. The concentration of atmospheric carbon dioxide has exceeded any value measured in ice cores over the last 800,000 years. This increase in greenhouse gases has led to global warming, which is evident in various indicators such as rising air and ocean temperatures, reductions in glacier sizes, ocean acidification, and sea level rise. In summary, climate change is profoundly affecting atmospheric conditions in both the Arctic and Antarctica. The Arctic is experiencing rapid warming due to the albedo effect, melting permafrost and increased wildfires, while Antarctica is influenced by the ozone hole, tropical storms, and rising greenhouse gas concentrations. These changes have far-reaching consequences for global weather patterns, ecosystems, and human communities.